Thank you for joining my session. My name is Michal Bryidyn. I am a security researcher, and during the pandemic, I did my research on how to find a way to access your AWS accounts using different small misconfigurations. And today I want to share my research with you. I'm also AWS ambassador, so that's why I focus only on getting to AWS accounts and not only not all cloud providers, but I will show you how I was able to get admin access to AWS accounts owned by different organizations. The first scenario is very simple. It's just HTML, and it's very easy to hack into AWS when developers store their credentials in JavaScript or HTML as a comment. So the first one, just preview the code, and you can find things like that. So we have HTML file, and there's a comment. Hey, it's a configuration, blah, 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 remove before production release. Remember about that, but I forgot to do that. And there's a piece of configuration file for AWS with access key and secret key. And these credentials already gave me admin access. So the first one, very easy to achieve. And believe me, there are many pages out there with AWS credentials directly in the code. I use different search engines to look for those, like Shodan, Census, Binary Edge. Sometimes it was Zoomeye, and all of them are evil search engines scanning the whole internet, IP by IP, port by port, indexing responses. So then I just need to know what I am looking for, and I ask these search engines and not the website directly to get these things. Then there's no noise in the network, and nobody knows that I already found what I was looking for. What went wrong here in the first scenario for the victims? So they left sensitive data in the code, and that's a big problem because first team creating something on dev thought that, oh, it's a good idea to leave a bit of documentation in the code for the operations team to let them know how to work with AWS, blah, blah, blah. But it's not a good idea because then the other team doesn't know if they need to remove something. So there are better places to store documentation, like your wiki or anywhere else, not in the code. Second scenario is interesting as well because it starts with GitHub, and it starts with a public GitHub repository. So I'm just looking into GitHub and trying to find whatever I'm interested in, and I decided to look for credentials in different config files. So there were many GitHub repositories with many different plain text credentials, but I found one repository with a config file where all these config variable names were plain text, but variables were encrypted. So a bit different than all these plain text. But this is something that I wanted to dig more into. So I was checking the whole repository, and in the same repository, there was a Java class with decrypt functionality and the encryption key, the secret key, hard-coded in it. So not that hard to use it to decode all values. These are some examples from directly from GitHub. You can see that we have database credentials here. We have mail sender credentials, so email and password, and these were from Office 365 probably. Then we have some other connection strings with endpoints, passwords, logins, etc. So a lot of sensitive information just to grab and use for the attackers. As I mentioned, there was Office 365 login and password, and when I grab that and I use my script to check if these credentials are valid and what they can give me, I found that there are many plans attached to that subscription, and yeah, it works. There's access to Azure Active Directory, to all thousands of users there. And there are also a plan for team space. So I was able to just open web teams and find whoever I wanted to say hi. So I decided to say hi to CTO, CEO, and other C-levels as well, just to let them know that there is an issue and they should secure it. But this was funny because they received the message from no reply at yourcompany.com, because that was the account that I found access to. But there is nothing interesting in Teams. But then there's SharePoint. And on SharePoint, there were many shared files shared with the whole organization, including a PDF file with Jira configuration guide. And this was not a generic configuration guide from the internet. It was a configuration guide created by a help desk team from that company. And it was a guide starting from not having Jira to having a fully configured Jira. So how they downloaded it, how they installed it, configured it, and the last step, how they created admin user and was the admin login and password. So I asked them later why they did that, and they said, "Oh, we are a junior help desk. We were told to document every single step we were doing to install that, and creating admin user was one of these steps. So that's why it's there." Okay, thank you for that. Using admin login and password to Jira, I just logged in because most Jira instances are in public internet, so anyone can just log in if they have credentials. And there was a simple login form, no federation, no Office 365, no other single sign-on, just login and password. So I used that and checked all projects. There were many projects with AWS in the name, but one of them was interesting because there was a task to create IAM user for external service, external CI/CD service, and this user should be admin. And as a response to that ticket, there was a comment with plain text access key and secret key to that user, and that easy. I just got admin access to this particular AWS account. Many small misconfigurations led to this one. What went wrong here? First of all, hard-coded sensitive data. Do not store your credentials in a repository. There are other tools for that, like Vault, like secrets managers, and you don't want to keep your passwords in a repository. Your team rotates, different people leave the team, and if credentials are in the code, they may have the code still on their machines when they are not working on the project anymore, so they can they can still use this login and password or access the secret key. Or if your repository leaks somewhere, there will be easy target for the attacker, because they will just grab plain text credentials from these config files. Also, when you decide to encrypt something in your project, do not store the decryption key next to a decrypt function. There are better places to do that as well. And I asked them why they did something like that. Oh, we wanted to be secure, so we encrypted everything. But why you store your encryption key in this Java class? Oh, because it's the only place we use that. Okay, yeah, seems like it. So thanks to that, I was able to decrypt that. And then when you push something to a repository and then you realize, oh, there's a password, there's a key, maybe I should override it. Yeah, that's a good idea. Override it, push a new version with a dummy value or no value at all, but then be sure to rotate the old value in the system. So if you pushed a password or access key, be sure these are not valid anymore. So when I get access to your repository and I run my tools to check Git history, there is nothing working anymore from this credentials perspective. So don't think like the guy there. I hope no one notices my credentials there. Then bad tool selection. First of all, public repository for commercial projects, not a good idea. In many cases, these are repositories created not by developers, not by project teams, but by help desk teams who want to automate their work, who are responsible for handling tickets, and many cases where they said that, oh, we need to respond to that ticket in 1 hour, so we automated the first email saying, yeah, we're working on it, and then we can sleep a few hours and then get to it. So they are not aware that there are better tools because they are not working with different projects. So if you see something like that, yeah, if you see something, say something. Let them know that they should use other private repositories and not a public one. Also, many cases where credentials were shared in a very risky way, like you created a new account for your new teammate to your systems, and you shared it login and password on his Slack or on Teams. But guess what? He's a new guy and he's a junior, and he's now sharing his screen, showing something to a group of people, and he decided to share the whole screen and not the window. So when you send him login and password, it popped up, and now he's still presenting for next 20 minutes, and his meeting attendees can just grab his login and password and play with his account. Also, lack of security awareness. Like the PDF file, it's not a good idea to to share credentials that's crucial, like Jira admin, in a place accessible by anyone in the organization. So too many viewers, like we don't want this there. And also Jira tasks and comments are not a good place to share logins, passwords, etc. Also, I noticed many incidents like sending someone an email with login and password or access keys, and adding more people to CC or to or other recipients, and then someone responding to all of it, and then 10 emails later, the topic is so long that nobody noticed that there's a valid login and password in the very first message. So please do not share both in the same channel. Share one in Slack, one in email, or use something like one-time links to want to provide a value for something like for password. And when you create documentation, just say that you created admin user and his credentials are secure in your password manager. Do not add login password to your documentation. And do not store it on Confluence or other place where you store your documentation. Sometimes people are also using their own Office 365 accounts or other enterprise accounts for shared tools, and these tools are created in a way that they, for example, log in to SMTP and send email. Or something like that, and then they store the code in a repository with their own login and password. So when I get access there, I have access to their private login and password for their user, and not some no reply at yourcompany.com. There are service accounts for these purposes. Just ask your admins to create one for you. Symfony profiler. It's not in Java, but it's a PHP framework. I used to work with PHP a lot, so that's why I knew how to hack it. And profiler is a developer tool. It's like a tool that's showing you what's going on in your app. It shows you all parameters, all configuration values. Also, in some versions, it can let you preview some files, like parameter files. But what's more important, it stores all request history when it's enabled, including your post requests to login page. It looks like that. We can see environment variables, and there are already some AWS credentials there, but these credentials like AWS S3 key and S3 secret gave me access to S3 only. It's good enough because S3 is a place where you store your files and your backups. So I was already able to extract a lot. For example, a Terraform state file that was stored there as well. But it's not enough. So I tried to find something else, and I went to a request history, found a request to a login page with login and password. And guess what? These credentials worked. So I grabbed them and logged into this dev environment, because it was a dev environment. But it was like dev.example.com. So I wondered, what if I remove the dev part from the address and just try to log in to production one? And it also worked. So using the same credentials stolen from dev, I was able to log into prod. And when I logged in, there was a dashboard with many internal apps and a single sign-on possible for many different applications like production CRM or webmail. And I don't need access to CRM. I don't want to see your clients, but I want to get to your AWS account. So webmail is something that I should check. And when I checked that, I noticed that there are AWS invoices on that in that inbox, and also trusted advisor emails. AWS trusted advisor, a service that tells you you pay too much or you forgot to secure something. So there are invoices, there are trusted advisor emails. Maybe this is a root user email. Let's try. But I don't have password. But there is password functionality, so maybe it will work, and it worked. No multi-factor authentication, nothing like that. I was able to just reset the password and log in to a root account. And on that root account, there was no MFA, and it wasn't a single AWS account. It was a root account of AWS organization's account. So instead of root access, full admin access to a single account, I just got access as admin to all member accounts, and there were many of these accounts there. And all this started from a dev environment of a Symfony profiler app somewhere. What went wrong here? First of all, production data on a non-production environment. If you have many environments, be sure you have a different set of data on each, not only PII or other customer data, but also passwords. If you have your account on dev, prod, stage, blah, 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 then please change passwords so each environment has different passwords. And it's very important because many times when I found something like that, the company said, oh, non-prod is out of scope for penetration tests, so we didn't even know that there's a problem. Yeah, I know, that's why I'm here. And if a customer says that, oh, there's a bug, but it only appears on the production, please dump the production database and restore it on dev and then debug it there. Please do not do that. You know how big is the data, you know the type of data there. Generate the same amount of data in your dev environment, and maybe this will solve the issue. This will help you solve the issue. You do not want to have access to production data. You don't want to be a processor of that data. And also, not in this in this case, but in many different cases, customers decide to use a single AWS account for multiple environments, or a single subscription for many environments in different clouds. And it's easier for them to just have one account and everything there, but it's also easier for me to get access to production data if I'm able to access non-production credentials, which leads to the same single account. So each environment should have a different cloud account just to separate your workloads. Yeah, and this one was interesting because the email address that I had there, the inbox, it was not only an email used to register for AWS, but for many different services like GitHub, like Office 365, and all these using a single email address because yeah, that's the address we use to sign up for different tools that we want to use. And I was able to get access to all of them just because there was a dev version of some app. And there is also a big problem with sharing account password, login and password with many people. You don't know then who did that, who did something else, and you don't know when to rotate the password because yeah, everybody using the same password, so nobody feels responsible for that. And there are also ways to work around that. There are tools that let you store login and password and then extract them and use, and then the tools rotate your password, so the next person that uses it will use a different one. And also you can add your MFA code there, so no need to have a single device for that. Please do not share your accounts. Create separate ones for each team member. No MFA. If you need to remember one thing from my presentation, remember to turn on MFA everywhere. Most of my attempts to get to your AWS accounts would fail if there is MFA somewhere on my way, but there's no MFA because if it's not required, people will not use it because it's not required and they don't need it. They don't want to have another 10 seconds added to their login process. So yeah, please use MFA. This will prevent me to getting access to your resources. Next one, Kubernetes. This one is interesting because during the pandemic, I noticed that many companies migrated to the cloud and they decided to use Kubernetes whenever they needed it or not. They were just using it. So many teams started to learn how to use Kubernetes, where to deploy it, how to deploy it. And while some of these teams were experienced enough to deploy it in a secure way, there were hundreds of Kubernetes clusters deployed in public subnets and with role-based access control disabled. So no security at all, and public IP, and anyone with kubectl installed on their machine was able to connect to that cluster and be admin there. So that's my scenario here. Kubernetes API publicly exposed. And using just a web browser, using just Chrome or Brave, you are able to extract secrets that are base64 encoded. You are able to extract config maps with your configuration details for different apps. Then you can also check the list of pods, configuration of each pod. You can also stage into any of these running pods or forward ports to your local machine. So you can access these private apps from your local machine. A quick example here. And we can see a list of pods with namespaces, names they are running. We can see config maps with SMTP configuration there, login password, all in plain text. And also we can see secrets. This is the output of my script to extract sensitive data from Kubernetes, public Kubernetes clusters. So it's already in plain text. Secrets are in plain text, but when you connect to a Kubernetes cluster and you extract secrets, then these secrets are base64 encoded, so you just need to decode them. And yeah, as you can notice, there is already accessing secret key here for S3, but I want more. S3 is not enough, so let's dig deeper. With secrets, as I mentioned, S3 access already there, but also on the list of pods, there was a Jenkins instance, Jenkins pod. Jenkins, the automation server, usually has admin rights to your environment because it's used to deploy your stuff, to build your stuff, to terminate your stuff. So it can do many things. And there were admin credentials in in secrets of Kubernetes. So I looked for that Jenkins, if it's public, if I can access it using jenkins.example.com. But it wasn't available in public internet. So I just forwarded ports 8080 to my port 8080 on localhost, and accessing localhost 8080, I saw Jenkins login page using Jenkins admin login and password. I logged in, and everything in Jenkins was mine. And then I started to dig and to trying to find what's there. Starting from workspaces. If you use Jenkins, you know that Jenkins is using workspaces to show you the code. It downloads the code from the repository to work on it, and this code is then stored in different workspaces. So you can see the code, you can preview all files, and then I found a config file with another set of AWS access and secret keys with SQS and Lambda access, but still not enough. So I was checking other places like Jenkins credentials. You need to know that any credentials stored in Jenkins credentials is not secure, because anyone with access to Jenkins console can decrypt whatever is there. And there was a GitHub login and password. I didn't have time to check what's there, but I knew that it worked because it was used in Jenkins. And also I checked console logs, build history, and there were calls to AWS using AWS CLI. So this means that Jenkins Jenkins has access to AWS CLI, and either it's configured as a role or in a profile with a long-living access and secret key. So using kubectl, I opened a bash on this Jenkins Jenkins pod, and I was able to play with AWS API using the AWS CLI, and it was admin access. So that's how, starting from misconfigured Kubernetes, I got full access to AWS account. What went wrong here? First of all, lack of knowledge, no experience. The team deployed Kubernetes, it works for them. So yeah, it's all fine. We have our functionality, but no security at all, because they didn't even know how to check this, how to secure it. And you need to remember that public resources are public. So anyone can access it if you forget to secure it with some kind of firewall or other security layers. And the other thing here, limited scope of pen tests, already mentioned before, non-production environments, out of scope. So they didn't even know that they are vulnerable. It's out of scope because it's cheaper. Let's focus on production, because then we just need a report from the pen test. We don't need a real full pen test. We don't want to be secure. We want a piece of paper to show our customers that we did it. And that's how it ends really, really bad. Risky design sometimes. Yeah, let's leave it wide open, because we have our team members all around the world, and we cannot whitelist their IPs because they work from home. They have dynamic IPs, or yeah, let's whitelist one IP and it's their current IP, but it covers half of London, for example. Then, if there are security features enabled by default, please do not disable them. I know sometimes it's easier if there is no security at all. You can do everything, and there are no error messages. But if you can do everything, I can do everything as well. So if there is a role-based access control, please use that. Please configure that in a way that only you can play with the tool. Sometimes I heard that, hey, it's a random IP. How did you know our random IP? Only our team knows the random IP, and that's why it's open. Yeah, I don't need to know your IP. Whenever you deploy something, a few minutes later, it's already indexed by one of the tools that I mentioned at the beginning, one of the search engines. Then if you store your data, then please encrypt the data at rest. Use some free time to implement the encryption for this data. And if the data is in cloud, it doesn't mean that it's already encrypted. That was one of the responses when I asked why they don't encrypt data. Hey, we use cloud; it's already encrypted. No, it's not. And yeah, no firewall, home office, dynamic IP, or no money for security solutions for VPN or something like that. That's a big problem. Yeah, you remember the first thing that I mentioned that you should remember, MFA. That's the second thing, principle of least privilege. Very, very important. It says that you should get only the permissions required to deliver what you're doing, to do your job, and not more than that. So it's a bad habit to give access, to give admin access to everyone because they may need it one day. You shouldn't do that, and you shouldn't give admin access to your new colleague who just joined the team and who is responsible for a small piece of your app. They shouldn't be admin because they don't know the app. They may do a mistake. And also, I heard many times that we gave them admin access because then they will not ask us for more and more and more permissions every day. Yeah, but that's how principle of least privilege work. You don't need these permissions, so please don't have them. Because if I get access to your account, then I will have these permissions that you have, and you don't need it, so why you have it? Unprotected CI/CD tools. That's an interesting one that may get our own presentation on it. Let's say that you have your non-prod and prod environments, and all developers have full admin access on non-prod environment and only read-only access to production environment. So they cannot break anything on prod. They can only see that it exists. But then you have your CI/CD tool like Jenkins or other automation servers. And these tools are configured in a way that they have full admin access on production as well. So if you as a developer have a possibility to create any job on that on that server, automation server, you can create a malicious one that will deploy malicious resources on your production environment that you don't have direct access to. But also there's another way to deploy malicious stuff on the production environment. You don't need to have admin access to your Jenkins or to your automation server. You don't need to be able to modify or even manually run these jobs. It's enough if you have access to repository. And these tools usually listen for changes in one of the branches, for example, the master branch. So if you have permissions to push anything directly to master branch without a pull request, without code review, then you can push a piece of Terraform with a resource for your cloud, like EC2 instance with a new policy attached, like admin policy, and it's deployed in the public subnet, with public IP, with your key, so you can log in and be admin there. And another thing, running apps as root, not a good idea as well, because if you're running apps as root, then anyone accessing these apps will be root there. There was a 0-day in Confluence in June this year, and there are many attacks on different Confluence servers because the 0-day affected all versions starting from 1.3, if I remember correctly. And this one is 18 years old. So all versions for the last 18 years are vulnerable, and it's still being actively exploited. And if Confluence is running as root, anyone can run any command using this vulnerable version of Confluence. So you don't want anyone to run anything as root on your servers. There are more ways in. I don't have them as separate scenarios, but I will quickly cover them as well. Outdated software running on cloud servers. This is something that started also from Flash products, Confluence, Jira, Bitbucket. In 2017, there was an issue that there was open proxy in one of the plugins, and using this this vulnerability, anyone with a Java web browser was able to ask for any URL to be opened in that Jira domain. So it can be Google, but it also can be a metadata endpoint of any cloud. And as we can see, there's the Jira version 7.3.3, and using the same Jira, I just added the part with plugins, plugins and the address of this metadata endpoint, and this gave me temporary access and secret key. There were many instances of Jira and Confluence there with this vulnerability, and some of them were even run on credentials of a root user. Someone created access and secret key for a root user of their AWS account and provided this to Jira instance. I don't know why, but yeah, it was there. So that's how you exploit outdated software. Please be sure to update your apps as soon as possible. Then we have admin credentials logged during the installation. Example here, I was asked by one of my customers to do an audit of their AWS infrastructure, and I got read-only access to their environment, and I was checking service by service, configuration by configuration, and then I found CloudWatch, so service to store logs. And in CloudWatch, I found a log from Jenkins installation. And this was the full log, including the last part, Jenkins login and password. So with the knowledge that there is a Jenkins and it's public, and with this login and password, I was able to log in and be admin in their AWS account. Then misconfigured virtual host with directory indexing. When you install your Nginx or Apache, you don't want to have this misconfigured in a way that you have a default vhost that points to one direction, but then you have your domain-related vhost configuration that points 2 folders deeper, because then you don't have your index file or anything like that in the root directory. And if I access your domain, I will see your page. But if I access the IP, I will see a default one, default for port 80, default for HTTPS for free, and the default will let me in 2 stories up, and I can just open it and see, for example, .env file. Debug pages and connection strings displayed for everyone. This one is an example from Python Django. And Python Django is doing a good job masking, hiding all values for variables like key, like password, like something like that. But then there's salary broker URL that consists of AWS access key and secret key. And these are plain text here. Many instances of that around the world, different IPs, different countries, many of them. So please make sure you don't have misconfiguration like that, showing plain text credentials as a connection string somewhere in your debug page. And that was the last thing. Yeah, thank you for being here. Thank you for listening to my presentation. If you have any questions, that's the time for that. I will open my chat now, and yeah, I'm here for you. Thank you. I don't see any questions in chat, so either it's not working or there are no questions. You can find me on LinkedIn as well if you have questions later. and I will try to help.